So when you move to a new neighborhood, right, the very first thing you do is build a mental map.
Oh, yeah, for sure.
You figure out the quickest route to work, you locate the nearest grocery store, you find the coffee shop that doesn't burn their espresso.
Very important.
Right. But instinctively, you are placing yourself right at the absolute center of this new, manageable little universe.
Yeah, I mean, it is a profound survival instinct. We are basically self-centric navigators by design.
Exactly.
We need a reference point to feel secure, and that anchor is almost always our own physical location.
But then, you open a map app on your phone and you zoom out and your street just vanishes into a city.
Right.
And then the city vanishes into a country. And if you just keep pulling back, like past the Earth, past the solar system, the entire concept of having a center completely shatters.
It really does.
Your little mental map becomes, well, just completely absurd.
It's the ultimate perspective shift, honestly. And, I mean, it is the ultimate existential ego check.
Which is exactly what we are putting you through today on this deep dive.
Good luck.
Right. So we're looking at an incredible stack of source material today, heavily inspired by the legendary astronomer Carl Sagan and his absolute masterpiece, Cosmos.
Such a great book.
It really is. And our mission today is to trace the journey of human cosmic discovery. So we're going to explore how humanity evolved from measuring the curve of the Earth with a literal wooden stick in the sand to fundamentally realizing that we are quite literally made of stars.
And we should clarify, we are not just doing a dry history lesson on math and telescopes here.
No, not at all.
Science is it's a philosophical lens. When you genuinely grasp the scale of the cosmos, it radically alters how you perceive your daily life.
Oh, completely.
Like a stressful email or a traffic jam, a missed flight. Those earthly dramas look very, very different when viewed against the backdrop of a few billion light years.
Yeah, and I want to start right there, actually, with the scale of it all.
Yeah.
Because my brain always struggles with this. Our sources don't even bother measuring the universe in miles or kilometers because those numbers just become completely meaningless.
Yeah, they just break down.
Right. So we have to use the speed of light. But the mind-bending part for me isn't even the distance, it's the time machine aspect of it all.
Right, that is the crucial shift in thinking. Because light has a cosmic speed limit. It's roughly 300,000 kilometers per second.
Which is insanely fast.
It is, but it still takes time for the image of a star to physically cross the void and hit your retina.
Meaning if a star is, say, 10 light years away, I'm not actually seeing it as it exists today.
No, you are looking at a ghost. You are seeing that star exactly as it was a decade ago.
Wow.
Yeah, every time you look up at the night sky, you are peering deep into the past. And considering there are, an estimated 100 billion galaxies out there containing planetary numbers with 22 zeros after them.
That's just, I can't even picture that.
You can't. We are effectively marooned on one tiny rock in an endless ocean of time.
Which makes our early attempts to measure this ocean just absolutely staggering to me. Because before we had orbiting space telescopes or, digital supercomputers, we had human beings in sandals standing in the dirt.
Literally.
Right. You look at a figure like Eratosthenes, a Greek mathematician living in Egypt about 2,000 years ago. He was the director of the Library of Alexandria, and he manages to measure the entire planet using nothing but a stick and a shadow.
It's wild. It remains one of the most elegant leaps of human deduction in history.
It really does. So how did he do it?
Well, Eratosthenes read an account stating that in the city of Syene, which is modern-day Aswan, at exactly noon on the longest day of the year, vertical objects cast no shadow at all.
Okay.
The sun was directly overhead, shining straight down to the bottom of deep wells.
But he lived in Alexandria, which is hundreds of kilometers to the north. So he waits for that exact same day, at that exact same time, and puts his own stick in the ground. And his stick actually does cast a shadow.
Right, which creates a massive geometric problem if you believe the Earth is flat.
Because if the sun's rays are coming down parallel to each other, hitting a flat surface, every stick should cast the exact same shadow.
Exactly. Or no shadow at all.
Right.
The only way you get different shadows at the exact same moment is if the surface of the Earth is curving away from the sun.
Okay, so proving the Earth is curved is one thing. That makes sense. But how does he jump from a slightly different shadow to calculating the circumference of the entire planet? Because that feels like a massive leap.
It does, but it comes down to beautifully simple geometry. Eratosthenes measured the angle of that shadow in Alexandria, and it came out to 7.2 degrees.
Okay.
He also knew that the distance between Syene and Alexandria was roughly 800 kilometers. They measured that by the time it took trade caravans to travel between them.
So he has an angle and he has a distance.
Right, and he realizes that 7.2 degrees is exactly 1/50th of a 360-degree circle. Yeah. So if that 800-kilometer gap represents 1/50th of the planet's turf, you just multiply 800 by 50. And he arrives at a circumference of roughly 40,000 kilometers.
He essentially nailed it. Over 2 millennia ago.
Yeah, it proves that the most powerful scientific instrument we have isn't a lens. It's the human capacity for reasoning.
But that brilliant reasoning had a massive blind spot, didn't it? Because while Eratosthenes gave us the accurate size and shape of our world, we completely misunderstood our address.
Oh, terribly.
We spent centuries utterly convinced that the entire universe revolved around us. Why did that illusion hold on for so long?
Well, put yourself in the shoes of a second-century astronomer like Ptolemy. His Earth-centric model wasn't based on stupidity.
Right.
It was based on perfectly rational daily observation. I mean, when you stand in a field, the ground beneath your feet feels entirely stationary.
It definitely doesn't feel like we're moving.
No, you don't feel like you are hurtling through a void at thousands of kilometers an hour. And when you track the stars, they appear to rotate around you in a perfectly predictable, massive dome.
It is incredibly counterintuitive to look at a stationary ground and a moving sky and conclude, actually the ground is spinning and the sky is standing still.
Totally.
Plus, being the center of everything really strokes the human ego.
Oh, absolutely. The geocentric model was psychologically comforting, but it had a fatal mathematical flaw.
The retrograde motion.
Exactly. As astronomers tracked the planets, specifically Mars, the math got really messy. Occasionally, Mars appeared to stop in the sky, move backward for a few weeks, that's retrograde motion, and then move forward again.
Which makes zero sense if Mars is orbiting us in a perfect circle.
None at all. So to fix the math, astronomers had to invent increasingly absurd looping suborbits called epicycles.
Just adding circles on circles.
Right. It was a mathematical nightmare. The system was basically breaking down under its own complexity.
Which forces Nicholas Copernicus in 1543 to finally pull the plug. He realizes the only way the math cleanly works is if he demotes the Earth.
Yeah.
Like, we aren't the VIPs at the center of the club anymore. We're just another planet orbiting the sun. So Mars wasn't moving backward. Earth was just passing it on an inner track.
Like a faster runner on a race course.
Exactly.
It was a brutal demotion. And then 60 years later, Johannes Kepler makes it even worse.
Because Copernicus still clung to the idea of divine perfection, right?
All right.
Assuming planetary orbits were perfect circles.
Right, but Kepler dives into the raw observational data and realizes the orbits aren't perfect circles at all. They are stretched out, messy ellipses.
The universe isn't a flawless divine clockwork. It's squished.
It's squished. And Kepler asks the crucial follow-up question. What is forcing these planets into these elliptical paths? He theorized there had to be some sort of invisible magnetic tether radiating from the sun, dragging the planets along.
So he is basically sketching out the blueprints for Isaac Newton's theory of gravity, decades before Newton's even born.
Exactly. He fundamentally shifted astronomy from just tracking the stars to questioning the physical forces that actually move them.
But, even after we accepted we were just a rock in orbit, we still couldn't let go of our ego entirely.
No, we just packed it up and projected it onto our planetary neighbors.
Right. And our sources point out just how hilariously wrong our projections were. Take the naming of the planets. The Romans look up, they see a brilliant, beautiful light, and they name it Venus, the goddess of romance.
Yeah, and Venus is the ultimate cosmic irony. It is a terrifying hellscape.
A literal pressure cooker.
It suffers from a runaway greenhouse effect where the atmosphere is 96% carbon dioxide. The clouds are literally made of sulfuric acid.
Okay.
The surface temperature is 480 degrees Celsius, and the atmospheric pressure would crush a modern military submarine like an empty soda can.
Not exactly the romantic getaway they envisioned.
No, definitely not.
And then Mars gets named after the god of war for its blood-red color, but it's actually just a barren, frozen desert. Though, that didn't stop us from hallucinating entire civilizations on it.
Percival Lowell in the late 1800s is the prime example of this. He points his telescope at Mars, squints at the fuzzy image, and documents massive straight lines crisscrossing the surface.
And he confidently declares them to be water canals.
He does?
And if there's a canal, there has to be an engineer. So the public immediately jumps to, Martians. An advanced, dying civilization building irrigation systems.
Right, but modern satellites proved there were no canals at all. Lowell was likely seeing optical illusions created by the lenses of his own telescope.
That's crazy.
Combined with the desperate psychological desire to find neighbors, we were essentially just looking for ourselves in the dark.
Which makes Carl Sagan's approach to the search for extraterrestrial life so refreshing, because he argued that our Hollywood conditioning ruins our imagination.
It really does.
We expect aliens to be, bipedal humanoids with big eyes because we evolved here under Earth's gravity, breathing Earth's air. Sagan asked, what if life evolves somewhere radically different?
He proposed this brilliant thought experiment regarding Jupiter, because Jupiter is a gas giant with no solid surface. Life there wouldn't have legs.
Right, there's nothing to stand on.
Exactly. Sagan hypothesized creatures that were massive, kilometers-wide floating gas balloons. They would regulate their own buoyancy in the thick atmosphere, and perhaps synthesize their food straight from sunlight.
Like airborne photosynthesizing jellyfish.
Basically, yeah.
It completely shatters your framework. But it raises a massive logistical problem. If intelligent life is as weird and foreign as a floating gas bag on Jupiter, how do you even say hello?
That's the challenge.
A creature like that doesn't speak English, it doesn't use binary code, it might not even use sound at all.
Well, Sagan and his colleagues recognized that chemistry and language are localized to a specific planet. But mathematics is woven into the fabric of the universe itself.
Right.
So he believed the universal greeting card would be prime numbers. 2, 3, 5, 7, 11.
Why prime number specifically, though?
Because a prime number is indivisible by anything other than 1 in itself. You cannot accidentally create a sequence of prime numbers through random cosmic noise or, a dying star.
It has to be intentional.
Exactly. If you aim your radio telescope into the void and pick up a pulsing rhythm of prime numbers, you know instantly, without a shadow of a doubt, that a conscious mind generated it.
That desire to reach out culminated in one of the most poetic missions ever launched. In 1977, NASA sent the Voyager 1 and Voyager 2 probes out into the dark.
Yeah.
They are the farthest human-made objects in existence, powered by the decaying embers of plutonium. And Sagan helped design the payload, the golden records.
They're literal physical vinyl records, encased in aluminum, with a stylus and visual instructions on how to decode them.
And what we chose to put on them says so much about us. Like, we didn't send schematics of our weapons. We sent greetings in 60 languages. We encoded the sound of wind, rain, a mother's heartbeat, and human laughter.
The logic was so profound. Human history is deeply scarred by violence and war, but Sagan wanted our cosmic handshake to reflect our highest ideals. If these records are intercepted millions of years from now by an intelligence we can't even comprehend, our first impression will be our art, our curiosity, and our capacity for joy.
It is a stunning achievement. But to even reach the point where we could hurl a nuclear-powered time capsule out of our solar system, that required a fundamental rewiring of the human brain.
It did.
To understand the origin of that scientific method, we have to look past the Voyager, past the Renaissance, all the way back to the ancient Greek colonies of Ionia.
Right, located on the coast of modern-day Turkey. Ionia is essentially the cradle of objective science. And it wasn't because they had better brains, it was because of their geography.
Okay.
Ionia was a massive, bustling trade hub.
So you had merchants docking ships from Egypt, from Babylon, from all across the ancient world.
Exactly. And in a closed society, everyone believes the same myths. If a storm hits, everyone agrees the local sea god is angry. But in a trade hub like Ionia, cultural mythologies collide.
Because everyone has a different story.
Right. The Ionians realized that the Egyptians blamed one god for a flood, the Babylonians blamed another, and the local Greeks blamed a third.
So they logically ask, well, if everyone has a different god taking credit for the rain, what if none of them are doing it? What if the universe isn't driven by divine whims, but by underlying rules?
That is the pivotal moment. The realization that nature operates on universal laws that can be observed and understood.
Wow.
In 430 BCE, an Ionian named Democritus pushed this to an incredible extreme. He deduced that if you take an apple and cut it in half, and keep cutting the halves, eventually you must reach a piece of matter that cannot be cut anymore.
And he called these invisible fundamental building blocks atoms. Which is wild, because he conceptualized atoms purely through logic. He realized that a knife slicing an apple isn't actually cutting solid matter. The blade is just passing through the empty space between these invisible particles.
It was a staggering breakthrough.
But I'm stuck on the timeline here. If Democritus figures out atomic theory in 430 BCE, why did it take us 2,000 years to actually split the atom? We basically put scientific progress on ice for a millennium.
We did, and we can lay a lot of the blame for that on the overwhelming influence of philosophers like Pythagoras, Plato, and Aristotle, whose ideas were later adopted by early religious institutions.
Right.
They established a dogma that the universe was a realm of divine mathematical perfection.
And if something is perfectly divine, getting your hands dirty to test it is almost an insult.
Precisely. They elevated pure abstract thought above physical reality. You could sit in a courtyard and philosophize about how objects fall, but to actually construct an experiment to test it was seen as flawed, vulgar, and eventually bordering on heresy.
Because asking why through physical testing was a challenge to the presumed perfection of the cosmos.
Yes.
So human curiosity is trapped in a philosophical cage. Until the Renaissance, when a guy like Galilei finally says, I don't care what the philosophy says, let's look at the actual data.
Exactly.
He supposedly drops objects from the Leaning Tower of Pisa, proving that gravity pulls on them equally regardless of weight, which tears down centuries of Aristotle's untested assumptions.
Galileo reunites abstract thought with physical experimentation. He finally breaks the dogma.
And once that dam breaks, humanity accelerates at a terrifying pace. We go from dropping rocks to questioning the very fabric of reality.
We do.
Which brings us to Albert Einstein in the early 1900s, a man who redefined the universe using nothing but thought experiments.
But unlike the ancient Greeks, Einstein didn't use thought experiments to avoid reality. He used them to push the known laws of physics to their absolute breaking point.
He found the glitch in the system.
He really did.
Let's walk through the core of his theory of relativity, because it breaks your brain in the best way. Before Einstein, we operated on Isaac Newton's logic. If you are on a train moving 100 kilometers an hour and you throw a baseball forward at 50 kilometers an hour, someone standing on the tracks sees that ball moving at 150 kilometers an hour.
Right. The speeds just add up. It's entirely intuitive.
Exactly.
But Einstein applied that same logic to light, and everything fell apart. He asked, well, what if you were on that moving train and instead of throwing a baseball, you turn on a flashlight?
Because under Newton's logic, the beam from the flashlight should travel at the speed of light plus the speed of the train.
But Einstein realized light doesn't behave that way. The speed of light is an absolute, unbreakable constant in the universe.
It refuses to budge.
It refuses. Whether you are standing still or hurtling forward on a speeding train, that beam of light will always leave you at exactly 300,000 kilometers per second. It never inherits the speed of its source.
So if the speed of light refuses to change, something else has to break to make the math work.
That is the genius of relativity. Speed is just distance divided by time. If the speed of light is rigidly fixed, then distance and time must be flexible.
So time and space literally warp.
Yes.
They aren't an empty, fixed stage where the universe happens. If you travel faster, time actually slows down for you relative to someone standing still. Space itself compresses.
He proved that space and time are a malleable fabric. It was a radical, fearless overthrowing of everything we thought we knew, and it sparked a technological explosion that directly fueled the space race of the 20th century.
Though looking at the history, the space race is soaked in a pretty dark irony. We didn't build rockets out of pure scientific curiosity.
No, he definitely didn't.
We built them to deliver nuclear warheads across the planet during the Cold War.
It is the great paradox of our era. The vehicles designed as instruments of ultimate destruction became the vessels for our greatest exploratory triumphs.
Driven by geopolitical fear.
Right. Russia launches Sputnik in 1957. 4 years later, Yuri Gagarin becomes the first human in space.
And the pressure is immense, forcing the United States to accelerate their program, culminating in 1969 when Neil Armstrong steps onto the moon.
Yeah.
In a historical blink of an eye, we went from trying to measure the Earth's curve with a stick in Egypt to leaving human footprints in the lunar dust.
It really highlights the dual nature of humanity. We are capable of immense destruction, but also unparalleled achievement.
Which brings us to the core existential question of this entire deep dive.
Yeah.
You, the listener, hearing this right now, why does any of this matter to your Tuesday afternoon?
Right.
How does knowing about Kepler's ellipses or Einstein's trains help you navigate your life?
This is where we return to Carl Sagan and his philosophy of the pale blue dot.
Yes.
When you absorb the reality of this scale, the billions of galaxies, the massive voids of time, our earthly conflicts shrink. The borders we fight over, the political arguments, the daily anxieties, they become comically microscopic. It strips away our arrogance.
It makes you feel incredibly small.
It does.
But at the same time, it makes you realize how unimaginably rare you are. Because as far as we can see into the dark, across trillions of frozen, boiling, toxic, or dead worlds, this fragile blue marble is the only place we know of that harbors life.
Exactly.
It is the only place that produces music, art, grief, and curiosity.
And we must remain humble, because astrophysics tells us that everything we can observe, every star, every nebula, every galaxy, makes up roughly 5% of reality.
Only 5%.
Yeah. The other 95% is dark matter and dark energy.
What exactly is that 95%? Like, what is dark matter?
Dark matter is essentially the invisible scaffolding of the universe. We can't see it, it doesn't interact with light, but we know it's there because we can measure its gravitational pull.
Oh, I see.
Entire galaxies are spinning so fast they should tear themselves apart, but this invisible dark mass is acting like glue, holding them together. We are swimming in a cosmic ocean, and we can only perceive the very top layer of the water.
That is deeply humbling. But there's a final poetic realization buried in our sources that ties this entire journey together.
Yeah.
When we look up at the stars, we aren't just observing distant fires. We are looking at our own ancestors.
Exactly. Because the gentle warmth of our sun doesn't have the energy required to create heavy elements. The iron in your blood, the calcium in your bones, the carbon in your DNA, those elements could only be forged in the extreme, unimaginable pressure of massive stars that exploded billions of years ago.
We are quite literally made of star stuff.
We are.
The atoms in your body were cooked in the heart of a dying star, scattered across the vacuum of space, pulled together by gravity to form this planet, and eventually evolved into you. As Sagan beautifully phrased it, we are a way for the cosmos to know itself.
It's beautiful.
The universe spent billions of years evolving eyes just so it could look back at its own beauty and a mind to wonder at its own existence.
It fundamentally connects you to the entire fabric of reality. You're not just in the universe, you are the universe.
Which changes everything about how we map our little neighborhoods. I'll leave you with one final provocative thought to mull over as you go about the rest of your day. If the cosmos spent 13 billion years violently forging the precise ancient stardust required to make your eyes, just so it could look back at the night sky, how does that realization change the way you view the very next stranger you pass on the street? Because beneath all the earthly drama, they are made of that exact same ancient stardust.